Thank you, Prudence. That was a pretty fabulous introduction. Yeah, welcome everyone. I'm not going to claim any titles of king of anything, especially not seeing a daycare that's probably larger than any building we've done ever from the first video. But I am going to talk about what we have been doing. We've been doing a lot of affordable multifamily passive house work recently. We are architects. There are a crew of us now in Maine, and it started out with me and my partner 15 years ago doing dormers and kitchen additions, and it's gotten bigger steadily ever since. We've got one unique thing is that we're all architects, but we have two passive house consultants. Just about everyone gets asked to do energy models, and we sort of forced down some of this thinking into everyone, whether they're a passive house consultant or not. And we do the consulting in-house, so we don't have to sort of go outside is a unique thing. We were actually one of only 27 architecture firms in the US last year to hit the Architecture 2030 carbon reduction benchmarks. And that is entirely because of the passive house territory. It got us on a path quicker than a lot of other folks. That, and I think also we don't tackle the really, really big hard buildings that a lot of big companies do. That's a nice advantage. But so we're in the first Portland, Oregon. Almost got named Boston, Oregon, but luckily they got named after us. We are a little city. We're the biggest city in Maine, 60,000 people. So we're kind of like the Alaska of the East Coast, I'll have to say. It's traditional to start your passive house show off with climate change peril slides. And so this is our climate change peril. This is our beloved oyster bar, which now floods every king tide. And it didn't do that literally 20 years ago when I got to this town. These tides did not come to the oyster bar, and they do now. So here's our thing we're trying to maybe not have happen. Be nice. You may notice by some of our greatest hits, this was one of the first passive house multifamily buildings in Maine on the East Coast, and it is bright enough colored that it ended up in a lot of presentations. And as Monty said, if you do one of the first ones, you probably have some of the lowest dollars per square foot, which we can't touch at all anymore. But it forced us, we're in a very frugal building climate. Maine does not build expensive buildings. It especially doesn't build expensive, affordable buildings. And so it just, coming up through residential renovation to multifamily, we're pretty frugal architects. This building is something I presented a bunch because we stumbled on this thing that Prudence was saying, like the stealth passive house. What if you're not getting certified? What if you can't get certified? What techniques do you hold on to? What do you do when your client doesn't even want you to do passive house because it might screw the project up? But we've been working really hard to make beautiful buildings for folks who may not have a lot of means on budgets that state agencies will approve. And then these past years have been this. I decided this is rendering to reality. Like about 3 or 4 years ago, this building was a rendering, and our city of Portland put out lots in downtown that if developers came and said they would build affordable housing or workforce housing, they would sell them city lots. And so this became a 23-unit building. These apartments have sold for $200,000. They're the cheapest home in Portland right now. These are apartments right in walkable downtown. This building it's not a passive house, but it's got a lot of the techniques that everybody in this room knows. And the scale is growing. We're getting bigger and bigger jobs. This is a 5-story podium building, a 60-unit apartment building. We are framing. We're going to go see the polished ground floor concrete tomorrow. And this is for Avesta Housing. This is funded under the Affordable Housing Program in Maine. It's a tax credit building for folks who work in that world. But yeah, so this has to meet all the most stringent budgets, and it also has very strong energy efficiency goals. But today, I'm here to unveil the trademark Nucifus system, the Northeast United States Passive House Enclosure System Package. Trademarked. Not really. It's all generic. You can all use this. This is the territory we work in to pull off passive house in affordable housing. And we've had to develop, we can't run new wall systems every time. We had to settle on something to be able to keep moving to get to scale. We were approached by a company in Massachusetts who develops affordable housing, and they work at scale. They work from Virginia to New Hampshire in affordable housing, and they only do affordable housing. And they have been, as state agencies up and down the country have started incentivizing passive house, they're giving bonus points in the competitive scoring round for affordable housing. They have been applying, and they started saying, here's an avenue we can get into. They saw us give a presentation. They called, hey, you know how to do affordable passive house at crazy costs. Come help us do this. And so we've been working with them in Connecticut and New Hampshire over the last years. And what they came to us and asked us to do was a passive house prototype. They said, we will have multiple building sites. Can you come up with a building that we could duplicate and use on multiple sites and not reinvent the wheel every time? And essentially be competitive across our region. And so this is a funny challenge. Now, you essentially have to have a building that you can use in multiple places, in multiple building environments, and you also have to be able to rotate it so it can work in multiple orientations, because you can't just face one side south and change it. And these are buildings that go in multiple complexes. So the first project we've been working on, which was awarded tax credits in Connecticut, is the Oak Tree Village. And you can see, so here are 4 of these buildings arranged around a central green, built in 2 phases with a clubhouse. So we've got the 2 buildings on the right coming first, 2 buildings later. These are 36-unit, 3-story wood frame buildings. This sort of very common multifamily housing type. This is not big urban construction. It's not rural construction. It's this like light frame wood, 2 to 4 to maybe 5-story buildings types that we build a ton of in this country. And here's our very, very efficient floor plan. Again, sort of through the crucible of affordable buildings, especially affordable buildings in Maine, we build very compact floor plans, double-loaded corridors, these simple wings that you can crack around a joint with your lobby in it and bend it to site, have a good entrance. Each building has a slightly different color at the accent in the middle, so you know which one's yours. You know where home is. You've got a place to maybe go have a picnic with your kids in the middle. A lot of parking. These are these funny, they aren't really rural, they aren't really urban. They're these suburban lots that they can acquire and affordably. A lot of car parking in these towns, honestly. Here's the next one. This is Cedar Point in Newington, Connecticut, outside Hartford. 3 buildings. This is an old auto dealership they bought. This is the kind of project these are. These are, these very, very real projects. 3 buildings at this one. Slightly different colors, slightly different roof lines. This is the prototype, getting modified. This is this funny, this isn't, where does this fit in custom high-end architecture? But buildings that can fit into these New England communities, they have gable ends to signal the scale that fits into these communities. Affordable housing is, trying not to have zoning wars. They don't want angry neighbors. They get angry neighbors just about every community they come into. So it's trying to be fairly conservative for design. So here's the first one. Here's the building site from the drone, and you can tell it's a passive house because there's our giant white cubes of insulation scattered all around. Our sub-slab insulation going in, the giant pile. 2 buildings and a clubhouse. You can see building going up, moving rapidly. Trusses over there stored. Multifamily building. This is familiar to anyone who works in this sector. Here we are partway through Ruffin. Yes, that's vinyl siding on these buildings. These are, again, very, very tight cost constraint buildings going up, but all working and committed to be passive house. And so here's the matter of the scale we're working. 144 units in Oak Tree Village. We've got 108 in Cedar Point, 81 in New Hampshire, 48 in Goffstown, New Hampshire. 380 apartments rolling out of our little group, all committed to passive house, all getting built in 2 years probably here. So what are we doing? How do we do this? What's the system that has worked for us? I'm here to spread the word to everybody working in these kind of buildings. These are trying very purposely to be big, simple boxes. These are slab on grade truss roof buildings, wood trusses, slab on grade, hopefully no basement. Very simple geometries on purpose, not a lot of jogs in and out, not a lot of roof line changes, things that you can air seal easily. You've got a flat air barrier in the attic, a flat one on the wall. We use exterior air barriers. Zip has been a savior for this market sector of not, everyone can buy it, everyone understands it. And then I think most importantly is what's the ventilation? The ventilation systems are by far the most critical thing we've realized in this, and that we are doing very good ventilation systems, like 85% efficient systems, and sort of these rooftop or in the attic, or maybe at the end of the hallways. Companies like Ventacity and Semco and Tempef and Renewair, these really, really high efficiency, maybe 12 apartments per unit per ventilation box. We're not one huge one, not hopefully one per unit. You are running it down the corridors, which are also crammed with tons of stuff, sprinkler lines and drain lines and hot water lines. But luckily they aren't insulated. They aren't moving heat and cooling. They are just sheet metal. Here's bad air leaving and fresh air coming in. And heating and cooling systems. These are often starting out with VRF systems. These people are all putting cooling in their buildings. These are not on the East Coast. Until you maybe get up to Maine, people really can't picture not having air conditioning in these buildings. And Connecticut, for example, is getting pretty hot these days. It's hotter than it was 20 years ago. So VRFs, big cost issue. These are expensive, complicated, computer-controlled systems, big refrigerant issues. There's really a lot of, it's very easy to sort of specify in the beginning, and there's this constant cost drag that you can't afford them in the end. Windows, we are doing almost always vinyl, triple glazed windows, casements and awnings. They are companies like Matthews Brothers out of Maine or Paradigm Windows, or there aren't European tilt turns. They are not that well insulated, and quite frankly, they don't need to be. Maintenance, durability, not confusing residents are really big issues, as are installing something with a window flange. Like this, after trying too many times to do flangeless installs, we just try to do flanged installs now on the outside air barrier that you can tape and seal just like every contractor's used to, and that not have a pick a fight over that one is a pretty normal technique for us these days. And then finally, after we've got through all that, what's the insulation values? Well, they aren't very high. We are 2 inches of foam on a 2x6 wall for these buildings. Maybe 3, 2.5. It's just, this is a code building in our climate. IBC 2018 or 2021. We just don't need a ton of insulation, we've discovered, and it's kind of come through the ring after we've gone through all these journeys. It just doesn't look like what we think of as a passive house. These truss roofs, one really critical lesson that we learned from other folks is a hard air barrier under the attic. So plywood, zip, something screwed to the trusses that's not spray foam from the top. It's not poly. It is a thing that slows down the electrician. It slows down the mechanical installers. It's really hard for them to cut through. They hate it. They curse at you. Nobody really likes hanging sheets overhead, but this is the thing that makes these air barriers work in these buildings. We're just completely convinced, and keeping lights and all penetrations out of these attics. We really, very minimal spray foam. Like the rim joists where the trusses land is about all the spray foam we're doing in these buildings. So really low low embodied energy insulations, cellulose, polyiso. We're not spray foaming these buildings, doing big, thick spray foam double stud walls or anything. Slab on grade buildings, we're trying for those. Sometimes we have basements, but we're looking at 3 to 4 inches of foam under the slab. It's not the foot thick foam of the old passive house single family archetype. We are thermally breaking them very carefully, but we don't have a lot of room. Our walls aren't that thick, so we don't have a lot of room to hide a giant thermal break. So we have a thermal bridge here. We put a little exterior foam, we warm it up, but it's, this is, it's a pretty good construction again. Almost invariably you get ready for the site team to very helpfully trim all the poly air barrier back, and you show up on site as they're pouring the slab and say, oh, we really, really need you to continue the air barrier out to the outside. Thank you for cutting it so neatly, but we would much prefer this. And they on the first one, and by the second one, they've sort of got it that you need to leave the flap long and tape it to the outside of the wall, and you need to, get this under slab air barrier really, really, really well done. So here's our sort of insulation levels. This is what we're putting in these buildings: R20 plus R12 continuous, R30-ish, R49 roof, R46. Anyone who works in our climate, these are code. This is, there's the building code. R20 plus R3.8, and here we are at R12. Like, we are not trying to talk about our insulation. We don't want it. We don't want it to attract attention. We love that it's basically code levels, because it stops the cost-cutting fight that everyone's used to doing. They all know how to reduce insulation. Like, every contractor worth their salt can strip insulation out of a project. But if you're down at code, there's nothing to push against. One really critical thing is, quality assurance and quality control, I will say, is absolutely, like, this would not work. We are barely pulling this off. If we didn't have a team like Stephen Winter in doing Energy Star inspections and HERS inspections and testing out the ventilation systems, something would fall apart. The ventilation systems never work. It takes 3 or 4 visits to get these things balanced. It seems invariably, like, it's hard to pull off. People like Carla Butterfield out on the site, pulling her hair out, trying to get people to do it, and blower door testing these things. This is, we don't have the hours to spend to walk through and inspect every stud wall. It just wouldn't work. So here's an example. Here's the next one. Hudson, New Hampshire, another 45 units with another 36 unit building rolling. This is, they are now framing, and they are in a cost crunch, and we are redesigning the ventilation system as we speak, with walls being framed. They're trying to move from central rooftop units to 1 ERV per apartment. Like, right now, ASIs are flying. We've got design build mechanical contractors on the phone. It's, it is in the middle of a COVID era. It's a little frightening, but we're getting units built, right? So here's our key lesson for you all. This, I think, is the dream of the passive house consultant architect, is that this is just how cool you are pulling all these buildings off, driving down the road. The reality is you are really building a car as you're driving, taking the wheels off, working on ventilation system. It is, our team is, there are moments when there's a lot of stress in the air, saying that you're going to pull this off. Another thing we've realized is there's a common language among us passive house people. Then there's a common construction knowledge. You're sitting there using the same words and they aren't lining up, is a feeling you have in these meetings. Kai, who I work with, just said it so beautifully. She's like, why are we the ones in the meeting who are explaining to the mechanical engineer that you can't take a 600 CFM ventilation box and get 600 CFM of air out of it? Like, why is the architect the one who knows that you have to run these at 60% of their max capacity? It's like, if you floor your car driving down the highway, it doesn't get good gas mileage. Like, why isn't everybody else? Why are we the ones who know this? So there's these moments of they're just, like, no, every single machine, 60%, start with that number. We have learned that you really need space, and you run your energy model to be 4 and not 475. You need 20% headroom in your buffer that you show your client, because something's going to go wrong. Something's going to slide. Your slab thermal break can be bigger than you thought. Your ventilation system is going to get redesigned mid-flight. It is not going to be as easy as you think. And then this big one, this is why I started with ventilation, is the ventilation comes first. And the great ventilation system in these buildings, and frankly, anything kind of bigger than a house and with a lot of people in it, it's the ventilation systems is absolutely key. And this building taught us it, because we were running energy models and we were sitting here staring at this building, which, hits passive house here. And, that top number in red, the 4.92, here we are, we're in that range of being a passive house. And we started running some scenarios, because you're always getting tested on these scenarios. And so if you take this building and you don't do this, you don't blower door test the heck out of it. Our state has a really good air tightness standard. It's actually tighter than this now, it's 0.2, but in Maine, every affordable housing building for over a decade has had to be blower door tested at a pretty good level. And if you met that state level, sort of building code air tightness, what we find is that the heating demand almost doubles just from that one move. And this isn't a bad airtight building. This is a pretty good building. So what if we backslide again? What if we take our really nice ventilation system and we do bath fans? Our heating demand doubles again. We go from 9 to 21 just by doing exhaust-only bath fans and a not very airtight building. You know, sort of the standard multifamily building. We've done 2 doublings. And here's the test that I love to show is that, you know, what if you have all the money and you do a ridiculous wall, like a 12 inches of foam on a, you know, this is a silly wall. We'd never do this. But so our 54 walls, we've got, you know, 18-inch walls, R44 under the slab, the classic passive house foot of foam under the slab, and R145 in the attic. You know, like it's more cellulose than my height. This is like the Duluth, Minnesota single family passive house from 2001, you know, those levels. We are at 16. We have clawed our way back from 21 to 16. We're nowhere near 4.75 with this. And we just bought all the insulation in the world. So, you know, the jump between this and this is not the insulation. And here's the, you know, here's a chart so you can see it all at once. This ratchet down from passive house to maybe modern building code airtightness to bath fan ventilation, and then, you know, try and get back. You can't get to passive house here. And then one more slide, you know, just a little bit of numbers today. That building, that white building, had a heating load of 50,000 BTUs an hour. That's half of a single family gas boiler in heating load. Just relaxing the air tightness doubles that, and all of a sudden we're at that box. And I will say this has been more potent an argument when I sit around tables with owners to talk about heating system size, because they don't want to spend more. And when you tell them, I'm sorry, we have to go buy bigger equipment. We have to, I know we can save money there, but we have to now go buy more heat pumps. You know, we're at 160,000. That's when they hit their limit. They don't really care about consumption and energy savings deeply. They do care about spending more money. And so you have to have a scenario where you're showing them they're going to spend more money. It's one of the key things we've seen. Here's another thing. We feel like airtightness is way underpriced. Here's a budget cutting run we did on a project. You know, we had to get 5 to 10% out of this building. Really, really tough moment on a affordable housing job. And we've got the air conditioning system on the chopping block. $300,000 to strip the air conditioning from this building. Nowhere in this budget does it say, relax the air tightness and I'll give you this money back. Because the contractors kind of don't know. They don't really have a number in there to go from passive house air tightness to this. It's in the labor, it's in the tape, but it's never in the line item here. And so it doesn't get challenged the same way. So this is our secret weapon. We can do this. All it takes is contractor training. One last piece. We have learned this the hard way, which is these this idea I learned in the passive house training of, you know, 1/3 of your heat comes from the sun, 1/3 for internal gains, 1/3 from a heating system. The easiest way in a house to get to passive house is to put tons of windows on the south and crank the solar in and get free heat to push you into passive house. If you do this in a multifamily building, you try to, you know, we are doing passive house, we're not doing passive solar house. If you do this in our buildings, you will overheat these buildings badly. And it took this map that someone showed me years and years ago, that Germany is the purple thing, and that's sun that the United States gets. And the only place in the United States with as terrible sun as Germany is Seattle. And New England is like northern Spain, which is a really sunny place. And so if we do lots of sun on the south of our buildings, we do huge windows in a multifamily building, or even worse, your apartment only faces west. Most apartments only face one direction. You're going to make a little solar oven. So we have very low solar heat gain in these buildings. Like really, like it looks crazy to us from the old days. And then my last lesson is keep learning, keep showing up at events like this. We didn't make any of this up. None of this is, we didn't develop anything in this slideshow. We learned all this from smarter people than us who had blazed other trails. So rooms like this are where it all happens. So that's my little pitch.